Okay, so now we go with one that's just a little bit harder. Now we take a rifle that's shot at an angle. A rifle with a muzzle velocity of 170 meters per second is fired into the air at an angle of 15 degrees. Now I draw this triangle out. It says calculate the total time the bullet is in the air, the maximum height of the bullet, and the range of the bullet. In other words, how far it goes. So the first thing is we got to break this down into horizontal and vertical components. And we use that using sine and cosine. So this is 170 meters per second here. So sine equals opposite over opposite over hypotenuse. So sine of 15 degrees will equal opposite over 170. So sine of 15 times 170 will equal this opposite angle. So the opposite, the velocity in the vertical direction, Vy, equals sine of 15 times 170. So sine of 15 times 170. And our initial vertical velocity equals 43.99 meters per second. Now we got to find our initial vertical velocity, so we use initial horizontal velocity. So Vx equals cosine of 15 times 170, which equals 164.2. Okay, the next trick for finding how high this thing goes and how long it's in the air is if this lands at the same height that it started at, we can use a trick which is at the top. We know that the vertical velocity at the top is always 0. So it starts out shot at 43.9 meters per second upwards, and it's going to slow down, slow down, slow down, and it will be going 0 meters per second up and down at the top, and then it will speed up the rest of the time until it hits the ground. The horizontal velocity doesn't change, but the vertical velocity reaches 0. So we can say that when it reaches the very top, velocity final will be 0. So 0, we know that, I'll write this equation out first. Velocity final squared equals velocity initial squared plus 2 times the acceleration times the distance. So I know that my 0 is my final vertical velocity is equal to my initial velocity was 43.99 plus 2 times negative 9.8 times the distance, and that will give me the height at the peak height. Now, why did I use negative 9.8 right here as the acceleration? Because the initial vertical velocity was upwards and the acceleration is downwards. So we have to show in our math that those are opposite. So negative 43.99 equals 2 times negative 9.8 times, whoops, I'm supposed to do that squared. Let's try this again. So 43.99 squared equals 1,935. And that's equal to 2 times negative 9.8. It's negative 19.6 times the distance, so I divide by negative 19.6. And I get 98.73. So distance is equal to 98.73 meters. That's how high this thing goes. How do I find how long the total time the bullet is in the air? Well, for that I can use the equation that says velocity final is equal to velocity initial plus acceleration times time. I know that at the top my final velocity will be equal to 0. And that will equal 43.99 plus negative 9.8 times time. I solve for time. And I get 4.49 seconds. and that's going to be half the total time it's in the air, because that's the time it takes to get from here to the peak, and then if we multiply that 2, that'll tell us how much time it takes to get all the way back to the ground. So we multiply that by 2, and this bolt will be in the air for 8.98 seconds. Okay, finally, the range of the bullet. We know that the horizontal velocity of this bullet will be the same the entire time, so that we know our change in distance will equal velocity times change in time. Therefore, change in distance will equal my horizontal velocity, which I calculated early was 164.2 meters per second. So it equals 164.2 times my total time of 8.98 seconds. 164.2 times 8.98 is 1,474 meters. Is how far this thing would travel before hitting the ground. Okay, last question. This time we're going to have a vertically or a non-horizontally launched projectile, but now it's not going to land at the same height that it started at. Now, say we're up on a cliff and we're going to shoot at an angle, but then it's going to fall some distance before it hits the ground, and we want to know how far downrange does it travel. What's the horizontal distance it travels? So I've got to start the same way. I've got to break the initial velocity into vertical and horizontal components. So a football is kicked at an angle of 33 degrees at a speed of 13.5 meters per second from the top of a 142 meter cliff. How far downrange does the football travel? So this angle is 33 degrees, and this is 13.5 meters per second. So I take sine of 33 times 13.5, and that will give me my initial vertical velocity, and I take cosine of 35 times 13.5, and that will give me an initial horizontal velocity. Sine of 33 times 13.5, 7.35 is my initial vertical velocity, and cosine of 33 times 13.5, 11.3 is my initial horizontal velocity. Okay, but now I can't use this. Last time we had a projectile that landed at the same height, and so we said that if we find the time it takes to get to the peak, then we just multiply that by 2, and we'll find out how much time it's in the air. But that doesn't work up here because it doesn't land at the same height. So if we were just multiply by this by 2, they would still have a lot longer than that to fall. So now there's only one equation that's going to work here, and we know that the change in distance is equal to velocity initial times time plus 1/2 acceleration times time squared. The change in distance, I know it has to fall 142 meters, and I'm going to put negative 142 meters in here because, again, this distance is downwards and its initial velocity is upwards. So we've got to make sure those values are opposite. So negative 142 is equal to my initial vertical velocity, 7.35, times time, plus 1/2, negative 9.8, negative again because acceleration is downward and initial vertical velocity is upwards, times time squared. And I'll solve that for time, and that will tell me how long it's in the air. Now, I could solve this by hand by using the quadratic formula. I would have to say plus 142, so 0 would be equal to some number t squared plus 7.35t plus 142. But with your calculators, you can just use the solve function. If you want to learn how to use the quadratic formula, we can talk about that some other time. So what I'm going to type into my calculator is solve, and then in parentheses I'll say negative 142 equals 7.35t t plus 1/2 negative 9.8, all in parentheses here, times t squared, and then I put comma t, so that means solve for t, and I just put that in. So negative 142 equals 7.35 t plus 0.5 times negative 9.8 times t squared, solve for t. And I get two values, one's negative, so obviously time isn't negative. So the time I get equals 6.19 seconds. So it'll be in the air for 6.19 seconds, so I know that how far does it travel. Change in distance equals velocity times change in time, because horizontal velocity is constant. Change in distance equals 11.3 meters per second, because that was my horizontal velocity, times my change in time of 6.19. Change in distance equals 69.9 meters. Okay, so those are basically the three types of projectile motion problems that you guys could have. If you have any more questions, just ask me about it in class. Alright, until next time.